That's this width times the rate of change that the knife is moving, yes? So that's the rate at which K sweeps out area. Yes? Okay, so what do you think this theorem is saying in terms of knives and areas? What's it saying? Imagine knife K starts at one end and moves to the other end, and knife L simultaneously starts at one end and moves it to the other end. And when they both start, they've swept out no area. They both ended, they swept out the complete cake. So what this theorem is saying is, if they both sweep out the total area in the same interval A to B, then at some point their rates must be the same, right? Because if one knife was sweeping out more area than the other at a greater rate, it couldn't be the case that they'd both start and end and sweep out the same area. It's basically what it's saying, right? Okay, so if you see that, then you see exactly what function to apply h to. So basically, here's the function you consider. Consider h of x, which will be f of b minus f of a times g of x minus g of b minus g of a times f of x. And this is, if you like, the difference in the areas swept by time x. That's the function to look at, isn't it? Why? Well, because then it's clear that h of a has to be what? At time A, when they both knives start, they both swept out how much area? Nothing, right? 0. It's also clear that by the time they both finish, the difference in area swept out is what? It's also 0. So if you have a function h that starts at 0 and ends at 0, then what can you conclude about this function? I mean, who knows what this function looks like? But would you agree that it must have either a maximum or a minimum, right? I mean, that theorem's true whether it's a max or a min, right? But there's some point where this derivative in between is 0, right? So by 1 implies there exists a c such that h prime of c is 0. Okay, but guess what's true about h prime? What is h prime if you calculate it? But h prime of x equals, take a wild guess. It's the difference between the right-hand side. Is it the right and the left or left and the right? It's the left-hand side minus the right-hand side of Cyclops Smiley. That's the argument. If you take a look at the book's proof, basically the book starts with this and then says, oh, take a look, ha, 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 look, these are satisfy the thing you need, but you have no intuition where it comes from, right? So this is the picture that helps make that precise. Okay? Okay, so this is basically the workhorse to do most of the problems in Chapter 5. Next time what we're going to do is I want to tell you about one other theorem about derivatives, and that's Taylor's theorem. And it wouldn't surprise you that Taylor's theorem is proved using the mean value theorem. Okay?